Welcome to this edition of Math Dive in About 5. Today we will be focusing on numerical patterns. I'm Barbara Knox.
And I'm Daryl Frost. Welcome.
So here is your first task. I'm giving you your first four terms of a pattern. They are 9, 13, 17, and 21. I want you first to write a description of what's happening in the pattern, and then try to write an expression that describes the rule. Once you have your expression, determine the 25th term in the pattern. I'm showing you an input-output table. Try to complete that table for the rule. 100 minus 2x.
So there's two different tasks.
Two different tasks, yes. Here is your progression with BEST. I think the biggest difference from 4th to 5th grade is that in 4th grade they're being given the rule, and in 5th grade they're going to create the rule.
It says generate.
Generate, describe, and extend the pattern that follows a given rule.
Okay.
So in 4th grade they are given the rule. In 5th grade,
I'm glad I asked that because I could see that being
they're writing the rule.
Yeah, they're writing the rule.
They are still using, if they're given a rule in 5th grade, they still are extending that pattern in a 2-column table.
Okay. With it like
using inputs and outputs.
Inputs and outputs.
So this is what you were given, and as the first task in your initial task slide, I gave you 3 terms in a pattern and asked you to basically come up with a rule.
4 terms, right?
4 terms, right? I can't count. It's all right. Anyway, we're going to model this concretely using tiles. So here I've got term 1 is 9 tiles, term 2 is 13 tiles, which is 4 more than my original term of 9, right?
I like how you're making this concrete,
right?
With a square tile.
Then I'm going to build my 17 with yellow tiles. I have to consider the 4 that were different from the first term to the second term, and now I've got 4 more in the third term.
Right.
So I'm starting to see a pattern. I'm wondering if that pattern is going to continue in term 4. So here I have term 4. Do I have groups of 4?
Every time
I'm adding
4
more
to the next number in the pattern.
I am. So what do you think my rule would be?
You're adding 4 to generate the next number in the pattern. So the rule is adding 4.
Well, there's adding 4 in there somewhere, but I have to go back to my original term 1.
Yes.
And I have to think about that add 4 rule, and I have to add 4 to term 1, right?
So that would be
so I'm going to add 4 to term 1.
Right.
And now I can see my pattern. I start with 5 and add 4. So I multiply, right? Each term is increasing by 4. So I am multiplying 4 by the number of the terms. So term 1, 4 times 1.
Right.
But I have to add those 5 back in.
So that's interesting because I think that'll be new thinking about, like, okay, you're given the term 1, but in order to show the complete pattern with all the numbers in the pattern, I had to add 4 to get the 9.
Exactly. In order to come up with the rule.
In order to come up with a rule.
Right? Because I know that I'm adding 4, so I've got 1 group of 4 here, 2 groups of 4 in term 2, 3 groups of 4 in term 3, 4 groups of 4 in term 4. So my n is the term number.
Okay.
So 4 groups, 4 times 1, 1 group of 4, 2 for the n.
Is the second term.
Right. So 2 groups of 4, which is 8. My third term is 3 groups of 4, which is 12, but I still have to add that 5 back in every time.
And there you go. So I think the language is critical there.
Yes.
So Barbara, looking at this is the second problem, right?
Yes.
Task from the beginning. How do I connect that? Because it's very abstract. How do I connect that rule to that input-output table?
Well, my input is actually the term X, right?
Okay,
So whatever input is, I'm going to start with the 0.
okay,
If I replace that X with a 0, then I'm going to multiply 2 times 0, which gives me 0.
right.
Subtract 0 from 100, and
I
I
have
get
100.
100. If I put 1 in place of the X, then I'm multiplying 2 times 1. I get 2.
And I'm substituting, which is algebraic reasoning
Correct.
language.
Correct. So I am then subtracting that 2 from 100 to get 98. I continue, right? But if I'm looking at term 23, I don't want to have to do all of the terms up to 23 to figure it out,
I
right? I
can
could
use
just,
the rule,
I can use the rule and replace that X with 23.
doubling it.
Doubling 23 is 46. I subtract 46 from 100 and I get my output of 54.
Double 47, that's 94. Subtract that from 100.
And I get my output of
6.
6. Now, Daryl, I know you had asked me about the rule for that previous task in the last unit. We're going to
Right.
actually address that here.
Yes.
So here are the blue and yellow tiles from Dive in 5 for our previous unit. We've got to figure out the rule. So what's happening?
Well, I know when I originally started looking at this, I saw that I was there was some adding 6 going on in the to get the total number of yellow tiles. But now that I understand, I have to think about that term and the term number. That really is the X.
So I'm looking at, if I'm just looking from term 1 to term 2, so 1 blue tile to 2 blue tiles, it increases by 2.
Right.
And all of these increase by 2,
Right.
but my rule is not going to be increasing by 2.
No.
I'm going to be multiplying by 2 for
Right.
the number of the term,
Yes.
right? But I've got to go back. So in all of these images, I have the 3 tiles on the left and the 3 tiles on the right.
Yes.
Those yellow tiles. I've shaded them with orange so that you can see which ones I'm
That's
referring
the 6 I was seeing.
That's
Yeah.
the 6 that is in every single term.
Right.
Now,
So
if
I
I
know I
look
need
at,
to add 6
if I,
somehow.
right, if I look at term 1, I have 1 group of 2. If I look at term 2, I have 2 groups of 2. 3 groups of 2 in term 3, 4 groups of 2 in term 4.
Yes.
And what do I have to do with the 6?
You have to add it.
So I am multiplying by 2, my term times 2, and then adding the 6
And
back in.
that rule will give you the number of yellow tiles.
Yes. All right, so on to our misconceptions. We have the task from the previous slide and previous unit.
Yes.
Think about this misconception only basing that rule on term 1 and term 2 and the change. What happened between term 1 and term 2?
There's 2 more. From term 1 to term 2, we added 2 more yellow tiles.
So what rule might a 5th grader come up with?
A common rule that would be a misconception would be X plus 2.
X plus 2. So if a student says X plus 2 is my rule, I need to go back to those terms and make sure that the rule stands true for every single term.
Right.
If I put 1 in place of the X, 1 plus 2 is 3. Are there 3 yellow tiles on term 1?
Mm-hmm.
What about term 2? 2 blue tiles. I replace the X with 2. 2 plus 2 is 4.
Nope, I should have 10.
What haven't they considered?
Well, and this is where it takes it back to the concrete. You have to look at how many consistent yellow tiles are there in each term. And I can see that if I think about the sides, there are 3 on the left side, 3 on the right side. There are 6 green tiles.
Yellow tiles.
Yellow tiles, excuse me, on the sides, if you will,
every
single term.
Correct. So I'm going to be adding those 6, and I have 2 yellow tiles on the ends of each blue tile. So
Yes.
I am going to multiply the term times 2 because for every 1 blue tile, I have 2 yellow tiles.
Yes.
All right, so going back to the concrete, representational, and abstract thinking, we started you off with the
Square
tiles and looking at the changes in those square tiles using a concrete tool. We, for our representational thinking, we're thinking about what's happening between term 1 and term 2, between term 2 and term 3, and so on and so forth. And we can see that 4 are added every time. But what we're not considering is that that 4 was also added to
the 9.
the number 9.
And that's, I just want to reiterate or kind of add to, go ahead and click on the rule. In order to make sense of that rule, we have to scaffold it back to the square tiles and everything that you saw on the slide, much larger, that something's happening to that first term as well.
Correct. Now, if I'm looking at the representational thinking, I can still think about, well, 4 had to be added to the 9 as well.
Right. So what did I
So
start with?
I can go back to term 0, which is what most people don't, and term 0 would have been what?
It would have been,
if I remove 4 from 9, I get,
it would have been 5.
so term 0 would be 5.
We don't normally
We
think
don't
about
normally
that.
start at
Term
term 0. Thank you for joining us for this edition of Math Dive in About 5.